no?
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay.
It's visible.
So you can see here. So the first part in for solving any problem, this is the last problem, students. So I'll be discussing the concepts yet again. So if you are not sure about these concepts, please just a moment. Please go through this once again and try to get the logic correct. Okay. So the first part is, you can see here the direction of current is already given. Okay, as it is given in, or they have assumed in a clockwise direction. Okay, so they have given us this as clockwise, so let me assume every current as clockwise direction in each loop. Okay, I have taken this as a clockwise. Okay, now always remember that the step one that we discussed, okay, was always related to the assumption of direction of current in individual loops. Okay, so this is individual loops we are talking about, and we have assumed the direction. Now step 2 is always, as we know, that step 2 is related to marking the polarity of the resistors. The reason for this marking of polarity of the resistors, to counter the, either it should be a voltage drop or it can be a voltage rise. Okay, now these are the two steps that we have to start with. Always remember. Okay, so now for marking the polarity, when we are marking, we have to understand a very basic and a very important concept, that current always tends to flow from, anyone, current tends to flow from where to where, students?
Sir, from lower potential to higher potential.
Again think and
From
say.
higher potential
Higher,
to lower.
yes, higher to lower.
Higher potential
Higher
to lower
potential.
potential.
Okay, and you won't make any mistake. Higher to low, higher to, sorry,
Higher to lower.
lower potential. Okay, always think about a tap. Okay, you can always think about a tap when you have a tap at your home. Okay, so always think in terms of a tap where water is coming. Okay, so you can think, you can always think in terms that it always goes from higher potential. Okay, from higher potential height in terms of potential energy to the lower potential. It always moves from where higher pressure is there to the lower part of the lower pressure part. Okay, in terms of your tap also you can understand this. So this is the condition for your current movement. Okay, so this is always there. So that means when I'm saying, I'll just mark this for you once again. Okay, so you have taken current like this. Okay, so current is entering here, so it will always enter at plus and leave at minus. Okay, current is going like this, so it is leaving this terminal. That means it is entering this terminal. So this is plus and this is minus. You can see current is moving this way. That means it has entered like this. So this will be plus and this will be minus. Here also current is coming downwards. That means it is entering here. So it will be plus here, minus here. Here also current is moving like this. That means in this resistor current has entered like this and came out like this. So this is plus and this is minus. Okay, and this is plus and minus already given in my circuit. So how this circuit is different from the previous one, that in the previous one you had one more resistor here, or this circuit was closed as it is, only one source was there. But here you can see that here I have two voltage sources at the two end of my circuit diagram, and based on this there will be a current analysis in my entire circuit. Okay, so now So you can take a snap of this. I'll just delete everything now. So right now, okay. So I told that we should start with KCL in this part. Okay. So let's talk about KCL here. Okay. So you will write applying KCL at node B. Okay. So since we are writing this for this, so we'll write it first that current incoming summation of incoming current should always be equal to summation of outgoing current. Okay. So at B, can you tell me what is incoming current, students? Can you tell me at node B, what are the incoming currents? Okay, I'll ask. Don't please don't, all of you don't say this. Dhanush, are you there? Dhanush, can you hear me? Uh, Dwaj Ranka, can you hear me? Dwaj Ranka. I hope I'm mm, saying your name correctly. Dwaj Ranka, are you there? Okay. Jacob, Jacob Joy,
I1 and I2.
Ivan and
I2.
correct. So you can see here I1 is coming like this, sorry, and I2 is coming like this. So incoming is I1 and I2. What about outgoing? Can you tell what is outgoing current here? So you can see that it is incoming like this and outgoing is like this.
20 amps.
So it is 20. So your first equation is this one. Okay. So this is my first equation. Let's talk about applying KVL in, sorry, applying KCL at node C. Okay, so somebody else. Nishtha Jain, can you tell me what is incoming current at node C?
So it is I3.
Okay, what about incoming, outgoing,
I2
and yes,
30 amperes.
yes. So it should be I2 plus 30. Okay, so this is your second equation and this is my first equation. Students, any problem in applying KCL at these two nodes? Anyone? Anyone having any doubt? Okay.
Clear, sir.
Okay, fine. Can I save this? We cannot. Okay. So you just write this equation 1 and 2. I'll ask you. Okay. Once I'll move to a different part. Okay. So let me now clear this all. So you have an equation in terms of I1 and I2 and in terms of I2 and I3. Okay. So can you tell me approach, like I am done with writing KCL equation. I want to write KVL equation now. Can you tell me like how should I approach? Please think first for 1 or 2 minutes and then only say. And here I have one thing as I1 plus I2 equal to 20 and I3 is equal to I2 plus 30. So 30 plus I2 is equal to I3. So these are my two equations. Please suggest me uh, uh, please suggest me to write an KVL equation In view of these two equations, how should I approach? Can you? Okay, somebody wrote in chat.
So we can take the loop ACFH.
A C F H. Okay, A C F H. Okay. Why you are saying this? Why you said like this? I mean, any reason behind that?
So we have I1 and I2.
Okay,
We
good.
have I1 and I2. So we will have two equations for I1 and I2.
Okay, okay. But if you can see this, the same equation I am writing, and please tell me, can I write like this or not? I1 plus I2 plus 0 I3 is equal to 20. Okay, now 0 I1 plus I2 minus I3 is equal to minus 30. Can I write these equations like this? Students,
Yes, sir.
Yes, sir.
okay, what I did, I
Yes,
just
sir.
wrote coefficient of whatever quantity is missing. I have just wrote that coefficient as 0. Here I3 was missing, here I1 was missing. Now, can you say,
Uh, Now, if
just
we take
now,
the loop A, B, C, D, E, F, G, H, the like only the outer loop,
okay, okay,
we'll get another equation that has I1, I2, and I3 in it.
okay, okay.
Then we can use the cross multiplication method to solve it.
Not cross multi. Yeah, we can. But why to go for cross multiplication? But when we can consider it like a matrix, and when we can put these
Same.
way, yeah,
That is
correct,
what I was saying.
correct.
Matrix that we learned in first sem.
Oh, okay, okay,
A
okay.
wrong
So,
name for the method.
okay, okay, correct, correct. Before that, who answered? Nishita, Nishtha. Who
Yes, sir.
answered? Okay, okay. So, Nishtha, now you got the logic. Can you extend your thought? You said like we can go till this part. So now you saw that we can convert these two equations in terms of three unknown. So for that three unknown, what we should do? We should go for the complete loop. Okay, so that we can cover I1, I2, and I3 also. Is it fine?
Yes, sir.
Okay, good. So now, so we'll be writing this again. So always students make it a habit like writing, applying KVL in loop A, B, C, D, E, F, G, H, A. That means outermost loop. Okay. So for that, the same thing that needs to be done here also. Minus plus current going like this. So enter at plus, leaves at minus. Coming like this, so enters at plus, leaves at minus. Coming like this, so enters at plus and leaves at minus. Okay, so why I'm not marking here, because I don't need, but still it is going like this. So enters at plus and leaves at minus, enters at plus and leaves at minus. Students, please be very sure with wherever current is entering is plus and where it is leaving is minus. And the concept behind this is current will always flow from higher potential to lower potential. Okay, now keeping this in mind and the logic that we always keep, like if we are moving from positive to negative, here we are talking about drop in potential, and drop is always associated with a negative sign. If at all we are moving from minus to plus or negative to positive terminal, here we are talking from lower to higher potential. That is always associated with rise, and rise we always take it as positive. Okay, so let's apply. Let's move from this side to this side, complete clockwise we'll move. Okay, so this is going from minus to plus, that corresponds to rise in potential. Rise is always associated with 110 volt. This is value given. Okay, so plus 110. Okay, now you are going from plus to minus. So what it would be, students? Plus to minus.
Drop, sir.
So it will always be associated with a minus sign. So drop is always I into R. Okay. Here drop and rise, whenever we are talking about IR drop or rise also in terms of IR. Okay. When we are talking about a resistor, not a source. Okay. So this is 0.1 into I1. What about this? I am going from minus to plus. So minus to plus is what, students? Minus to
Rise.
plus is rise. So
But
rise
in
is
the opposite
associated
direction.
with a plus sign. But
Minus 0.3 into
yes, yes, good, very good. So when I am talking about IR drop, okay, or IR in terms of this particular resistor, I'll write 0.3 into I. But current direction is opposite to your movement. You are moving in clockwise direction, but current is coming in anti-clockwise direction. So it will be 0.3 multiplied by minus I2. Similarly, when I come to this point, it is again from minus to plus associated with rise in potential. So plus for that. But since the direction of current is opposite to that of what we have assumed as direction of movement, so that will be nothing but 0.2 multiplied by minus of I3. Now again, I came to this part from plus to minus. So plus to minus is always associated with a drop, and it will be having a minus sign, minus 120 equal to 0. Okay, so students, please make a mark of this points, that whenever I am writing this I2 and I3, whatever is my movement, the direction of current is opposite to that. That's why I have to take a minus sign for these two current. Whereas for I1, whatever is my direction of movement, it is in the same direction. So it is plus here. Is it clear, students? Anyone having any doubt in this? So you can see here all places I have minus, and this is also 120 and 110, minus 120 plus 110 minus 10. So this equation will be 0.1 I1 plus 0.3 I2 plus 0.2 I3 minus 10 equal to 10. So this is my third equation. Is it fine, students, now? Okay, so now you're left with, you have to tell me I1, I2 equal to 20, I2 minus I. Okay, so I'll just write it down again. So I'm left with I1 plus I2 is equal to 20. Okay, it's gone. Okay, so can you tell me the equation, students? I1 plus I2 20. Can you tell me the other two if you have written? Okay, I think you haven't written. So this is I3 is equal to I2 plus 30. And that one is 0.1 I1 plus 0.3 I2 plus 0.2 I3 is equal to 10. Okay, so now when I wrote if I can write this in terms of I1 plus I2 plus 0 I3 is equal to 20. Sorry. Okay, and here 0 I1 plus I2 minus I3, okay, is equal to minus 30. And here it is 0.1 I1 plus 0.3 I2 plus 0.2 I3 is equal to 10. So this is in form of 1, 0, 0.1, 1, 1, 0.3, 0, -1, 0.2, and this is I1, I2, I3 is equal to 20 minus 30 plus 10. Okay, so this is the matrix that you have which you can solve using a scientific calculator. Can anyone tell me what is I1, I2 and I3 after this? Okay, so this is your delta. For third equation, it is plus 10 or minus 10. I think it was coming on left hand side minus 10. So if I'll move that on right hand side, it will be plus 10. Students, can you cross verify this one? Anyone? It should be minus or plus 10. Okay,
So it's plus only, I believe.
I can verify for you if you are asking. Okay.
So do you have to do the del 1 by del, and then del 2 by del, and then del 3 by del?
Yes, obviously. Okay. So here you are asking what it should be. So this is 110 minus 0.1 I1. This is minus 0.3 I2, and this is minus 0.2 I3, minus 120 equal to 0. Okay. So this all are minus now. So I can write it as 0.1 I1 plus 0.3 I2 plus 0.2 I3 minus 10. So minus 10 will go to this side. Okay, so minus 10. Okay, it will be minus 10. Students, please make it as minus 10. Okay, because all this will be negative. So if I'll make everything as positive, so it will go this side and be minus 10. Okay, so this is minus 10 here. Good. Minus 10 here. Okay, so this is minus 10. So yes, someone asked. So this is my delta, and if you want to say about delta 1, so you have to replace this column with this constant value. That is 20 minus 30 minus 10, 1, 1, 0.3, 0, minus 1, 0.2. Similarly, your del 2 will be, your second column will be replaced by this. So this will be 1, 0, 0.1, 20 minus 30 minus 10, 0, minus 1, 0.2. Okay. And similarly, your del 3 will be, your third column will be replaced by this. So this is 1, 0, 0.1, 1, 1, 0.3, 0, minus 1, 0.2. Okay. So these are your del 1, del 2, del 3. So to write I1, you have to do del 1 by del. I2, you have to do del 2 by del, and for I3, you have to write del 3 by del. Okay, so this way we can solve. Yeah, I have a class now again. Just a moment. Hello. Yeah, good morning. Yes. Yeah, I'm starting. Actually, I am in a department meeting also. I have started, and one class is also going on. I'll start in 2 or 3 minutes. Yeah, I'll start in 2 or 3 minutes. Yes. Please ask your classmates to just wait. Okay. Okay. So I'll show you one thing, important thing here.
Sir, del 3's third column is wrong, I guess. So.
Okay, we'll just cross verify this for you. Okay. I just want to show you the exact steps so that you can cross verify from here. Okay. So you see here, okay, so you can see here I1, I mean, we applied KCL at node B and C both. Okay. So we have applied KCL at B and C, both the nodes. Okay. And then we apply KVL at the outer loop to get three equations using calculator. If you will solve this, you will definitely get I1, I2 and I3 here. Okay. So somebody was saying about the third or the fourth. So you can see here, you can take out that 0 point also, because everywhere you have, so you can multiply with 10 everything. So finally you are getting something like this as 1 1 0 0 minus 1 1, and here as 1 minus 3 minus 2. Okay, so these are the coefficients of I1, I2, I3, and this is equal to 20, 30 and minus 100. Okay, so this is what you have got as your equation. So you have to solve using calculator, scientific calculator, and finally you will get the value of I1, I2 and I3 as 10, 10 and 40. Okay, now you can apply your KVL in loop ABGHA. ABGHA. So when you'll apply KVL here, you will have relationship between I1 and R1. I1 value you know, R1 you can find. Similarly, in the next step, you will apply KVL in the this loop, outer loop. So you'll have a relationship between R2 and I3. So you know I3, you'll get the value of R2. So here's the same thing they have shared. You can see they have written relationship between I1 and R1. I1 I know as 10 amps. So I can put that value and get the value of R1. Similarly, I'll write KVL in this loop. Okay. So I have relationship between R2 and I3 here. I3 and R2 here. I3 value I know as 40 amps. Okay. So I'll put that value and get finally R2. So this is your assignment, students. Okay, you have to solve and confirm R1 and R2, okay, along with I1, I2 and I3. This is your assignment for today. Any doubt? Anyone?
Clear, sir.
Anyone having any doubt in this?